Now that we know what the problem is, at this point, I'm going to give you a certain way to approach this problem. Obviously, we are not going to enumerate the solutions, but uh, we are going to define a new kind of arithmetic in a vague way, let's say, or in a loose way, um, to actually represent the set of solutions. Now, in this arithmetic, addition, as we know it, builds a list, or well, maybe it defines a set, if you like. Multiplication collects together. So what this means is going to be evident in a minute, I hope. Here are some examples so that you can understand better. Uh, when I omit the sign, of course, I'm going to mean multiplication. So these three pennies are multiplied, okay? And since it collects together, this will mean a solution for 3 cents. Okay, you have 3 pennies. So this is a configuration which gives you a total of 3 cents. Or if you happen to have like 2 cents as a coin, which we do not, as far as I know, uh, this would be another solution to 3 cents. So what we mean by this expression is, okay, you see I have multiplication in between these coins, but at the very middle I have addition. If you remember, addition builds a list. So what is this? This expression is all the ways to obtain 3 cents. Okay, so obviously this and this are the same. Okay, in some problems the multiplication that we define in this way may not be commutative, but in this case it is, because we are just looking at the total. And this makes 3 cents, this makes also 3 cents, so they are the same because they consist of the same denominations. And we will also represent a total of 0 cents with this empty uh, coin, let's say. Now, consider the list of ways to obtain any amount: 0 and 1 and 2 and 3, all the way to infinity. So this is a set, or a list, if you like, of all the ways of constructing an amount given to us, but using only pennies. Now, obviously, if you give any amount using pennies, there is just a single way to obtain that amount, because, well, penny is just one. So if you want the number of ways to obtain 15 cents, you just have to put in 15 pennies. There is no way around it. You have to put in 15 pennies. So that's just one way, no alternative. If you want to obtain like uh, 36 cents, then you have to put in 36 pennies. So that's the only way to do it. So I'm going to call the expression P as the list of all the ways, okay, to obtain any amount from 0 all the way to infinity. So it consists of 0 and 1 and 2 and 3 and so on. So I'm going to represent this as this power series. Okay, so 0 plus 1 plus 1 squared plus 1 to the power 3, etc. So this multiplication here will result in the definition of a power, if you like, in this arithmetic. Okay, so this is P. By definition, I define P to be the list of all the ways to obtain any amount using only pennies. Now, next step, if you also allow nickels, the one with 5, now you have ones with the pennies and 5 with the nickels, okay? I would like to obtain the list of all the ways to construct, again, any amount, but using pennies and nickels, okay? So you can use only pennies, you can use only nickels, you can use a combination. Okay, so all the ways are allowed here, but you just want to have pennies and nickels and not the others at this stage. Now, you have P. This is the list of all the ways to obtain any amount. Now, to this, if you add 0 nickels, you get all the combinations. If you add just 1 nickel, you get this shifted by 5. If you add 2 nickels, you get this shifted by 10, etc. Okay? So by adding any amount of nickels, okay, you will have any new ways to construct the amounts. So for instance, 5, the total 5 can be represented as 1 to power 5, but it's also equivalent to 5 to power 1. Why? Because 0 is equal to the empty coin, and if you add a 5 to this, you get 5 equals 5 to power 1. Okay, so here, well, we didn't really rigorously define it, but this is the identity, so you multiply it with any denomination, you get that denomination by itself, like so, and so on. Okay, so here, in summary, N here is the list of all the ways to construct any amount using only pennies and nickels. So this component corresponds to just P, because I'm multiplying with this empty coin, which is the identity, so this will give me P. In the next, I just add a nickel to each combination. So here, this will give me a 5, this will give me a 6, this will give me a 7, this will give me an 8, and so on. Okay, and this one, I'm adding 2 nickels. So this one will give me 10, this 11, this 12, this 13, and so on. Okay, but still, you see now 13 has more than one way to be constructed. If you allow only pennies, that's only one way, just 13 pennies, no alternative. But if you allow nickels also, you have now you have 13 pennies as one alternative, or you have 1 nickel and 8 pennies, second alternative, or you can have 2 nickels and 3 pennies. That's the third alternative. Now you have, for 13, you have 2 alternatives. And one of those terms come from this, the other one comes from this, the other comes from this one. These ones, the rest, cannot contribute to 13 because, well, you see, this is 15, which already exceeds 13. Okay, but now you see I have, instead of 1, I have now 3 alternatives for constructing 13. As the amount grows, I will have even more alternatives. Okay, but at the end of the day, N here represents all the ways to construct any amount, okay, 0, 1, 2, 3, 4, 5, 6, beyond through infinity, consisting of pennies and nickels. Okay, so that I can achieve by adding any number of nickels to P here. So this I can represent by this product here, again, the empty coin plus just a nickel plus 2 nickels plus 3 nickels, etc., multiplied by P. So this gives me all the ways I can combine nickels and pennies to obtain any amount. So very similarly, if you allow dimes, now tens come into the picture, the list of all possible ways to obtain any amount is now empty coin plus 10 to power 2 plus 10 to power 3 times n, because that the logic is the same. If you add any number of dimes to these construction ways, then you obtain new combinations. Okay, so this will be represented with D, and it has all the ways, all the possible ways to obtain any amount with pennies, nickels, and dimes, ones, fives, and tens. Okay. Similarly, when you allow quarters, what you get is, again, this. This is 25 to power 0, so to speak. This is 25 to power 1, 25 to power 2, etc., all the way to infinity, times d. D is here. You get q, and q is the list of all possible ways to obtain any amount using ones, fives, tens, and 25s. And finally, you get h by multiplying q with this. Now you allow 50s, and this is the final expression you get.